Okay, so like I said in the beginning, your learning target is that you can logarithmically differentiate to find the derivative of a function that's too complicated to take the derivative of. So logarithmic differentiation is a method for taking the derivative. We'll summarize it in a bit, but let's just go through an example. So the calculation of derivatives of really complicated functions involving products, quotients, or powers, often, not always, but often we can simplify them using logarithms. We call this process logarithmic differentiation. So if I gave you a question like this on your quiz, which is really ugly, you could take the derivative. But look at how complicated it is, because overall you've got a quotient rule. And when you take the derivative of the bottom up here, when you take the derivative of the top, you have a product rule. And when you implement that product rule, you've got a chain rule, because both of these are composed functions. And when you take the derivative of the denominator in the second stage, you've also got a chain rule. So it's going to be really complicated to take that derivative. So we're going to do a process called logarithmic differentiation, and I want you to really make sure that you respect the equals sign. And you do the same thing to both sides all the time. Of course you know that, but it's easy to forget. So let's just start off rewriting our equation. Y equals, leave a little space here, and let's write it out again. X squared, and I'm going to write it in exponential notation, x squared plus 1 to the 1/2, and it's being divided by 3x plus 2. Oh, sorry, thank you. So x to the 3/4, x squared plus 1 to the 1/2, 3x plus 2 to the 5th. Okay, just rewrote the equation, hopefully correctly. Now I'm going to do the same thing to both sides of the equation. I'm going to take the ln of both sides of the equation. Still doing, so I did the same thing on both sides. So on the left, I've got ln y is equal to, and on the right, I'm going to take the ln of this whole complicated quotient and I'm going to spread it out. So this would be the ln of x to the 3/4, bring the exponent down, plus the ln of x squared plus 1 to the 1/2, bring the exponent down, subtract the ln of 3x plus 2 to the 5th, bring the exponent down. Okay, so we've simplified that. We've spread this out as much as we possibly can. Now I'm going to do the same thing to both sides of the equal sign. I've got ln y is equal to 3/4 ln x plus 1/2 ln x squared plus 1, subtract 5 ln 3x plus 2. What am I going to do to both sides? I'm going to take the derivative with respect to x. The derivative with respect to x. I've done the same thing on both sides. On the left side, I'm taking the derivative of ln y. Oh, that's 1/y. But if I'm taking it with respect to x, I need to multiply by the derivative of the inside function. It's a chain rule. Is equal to, I'm taking the derivative with respect to x of each of those three terms. Okay, so first one, I'm going to use my constant rule, take out the 3/4. The derivative of ln x is 1/x, plus, take out the constant 1/2. The derivative of ln x squared plus 1 is 1/x squared plus 1, chain rule, times 2x. Take out the constant, subtract 5. The derivative of ln 3x plus 2 is 1/3 3x plus 2, chain rule times the derivative of the inside function, which is 3. So 1 over y times y prime is equal to 3 over 4x. Just going to algebraically clean this all up. Plus a half times 2x, the 2's would cancel. I just end up with an x on the top and an x squared plus 1 on the bottom. And 5 times 3 minus 15 over 3x plus 2. And then last of all, I'm going to multiply, same thing on both sides of the equal sign. I'm going to multiply both sides by y, so that I end up with y prime is equal to y times all of that. And what's y? Well, this is y. Y is x to the 3/4 square root x squared plus 1 over 3x plus 2 all to the 5th. So there's the y times 3 over 4x plus x over x squared plus 1, subtract 15 over 3x plus 2. And pretty simply got our derivative. Okay, if we get all fussy about this, we give things common denominators, we combine them and collect like terms in the numerator and see if anything cancels and factor it all. We're going to leave it like that because I think that's enough for now. So just a quick summary, here's your steps in logarithmic differentiation. You take the natural log, i.e. you take the ln of both sides of the equation. Okay, so that's what we did right here. We took the ln of both sides. Okay, so I always want to make sure that you are remembering you respect your equal sign. Okay, then we just simplified using log laws. Ln, laws, same thing. Okay, so expand all of this. Then the derivative of both sides. And then from there, after we've taken the derivative of both sides, then we're going to simplify. And we're going to substitute y in here. Okay, and this derivative of both sides means you're going to need to use implicit. Right? You got 1 over y prime.